Question number 14. Diagram 11.1 shows the relation of three sets. State GF. Okay, so we can see that it starts from set A. Okay, this is the input because it's X here, and it goes through F function to get this, and then G function to get this. Okay, now the G function here is not GX. I mean, yeah, it is. It's not GX. It's not this. It's actually G. The input is what? X minus 2 equals to x squared plus 1. Okay, this is actually the function. Okay, it's not gx. So we cannot use this. I'm just letting you all know. I know some people will get confused. Okay, they will think that is gx. That is not gx. So this is fx because you're starting from the x and you get this, correct? So okay, let us just label. So we know fx equals to x minus 2. And since we're looking for gf, so I think I told you all before, when it comes to function, right, we always read from right to left. So if you're looking for gfx, that means it goes through fx first, then it goes through gx. Okay, so it goes through fx first here, then it goes through g function is here. Okay, so in other words, we're looking for this lah, because we end up in this position and it started from here, so we are looking for this. So this one will represent gf. Okay, that will represent gf. So gf equals to, so from x became x squared plus 1. So x squared plus 1. Okay. Alright. Question B. B1. Determine f inverse and find gx. Okay. Alright, let us do here. Question B1. So we find f inverse first. So we already know fx is x minus 2. So let fx become y so that we can rearrange. So now we make x the subject. So we bring the negative 2 to the other side. So we get y plus 2 equals to x. So now this x here, it will represent the f inverse lah. So now it becomes f inverse x equals to the y plus 2 now becomes x plus 2. Okay, so that's the inverse. Okay, so done with that. Hence find gx. Okay, we don't have gx. I know as I said just now, some people are going to assume this is gx, and then they write gx equals x squared plus 1. This is wrong, because this is not gx. Okay, this is actually g x minus 2. Okay, because you didn't start from x, you started from x minus 2. Okay, so how do we find gx? You have to find gx by using okay, let me write here. You want to find gx, right? But you only have gfx. So what you have to do is you have to remove this guy. Remove this guy. So how do you remove? You cannot just cancel. You have to, I call it neutralize. How do you neutralize? You substitute a negative, an inverse here. You substitute an inverse. Why we substitute an inverse? Because when there is a forward and an inverse function, it becomes x. Okay, you neutralize it, it becomes x. So in the end, you have gx. Okay, because this 2 becomes x already. Okay, so that's what we're going to do. We are going to substitute the inverse function, the fx, f inverse x. You're going to substitute into the gf function so that you can neutralize the f. Okay, I hope you all, oops, sorry, my bad. Okay, I hope you understand what I'm saying. So gf, then we're going to substitute the f inverse. So the f inverse here is x plus 2. So the x plus 2 you're going to substitute into this gf function. So instead of x squared plus 1, it becomes x plus 2 square plus 1. So you can expand this. The shortcut is what? You square this, so you get x squared. You square this one, you get plus 4, so it becomes plus 4 here. Then the middle number here is this times this times this, so you get 4x plus 4x and then plus 1. So you have x squared plus 4x plus 5. So this will be, so you already neutralize this lah. Okay, you already neutralize. So now you have gx. So this is your gx. Okay, x squared plus 4x plus 5. Alright, next. Oh wait, this is the first one. Okay, the second one, they are saying what? Diagram 11.2 shows part of the graph y equals to gx. So this is the y equals to gx graph. And what are they asking for? Sketch the g inverse. Okay. Whenever you have a function and you want to draw the inverse, it's basically a reflection. A reflection at which line? At y equals to x line. Okay, it's basically a reflection here. So this will be y equals to x. This line is y equals to x. And you just have to reflect that function, that graph, using this as the mirror. So that means the 0, 0, 9 here, 0p here will end up at this point. Okay, wait, let's say here. Reflect, right? So it's here, this part. This part. So this will be, instead of 0p, it becomes p0. Okay, p0. Because it's already reflected, right? And this point here, when you reflect, it maybe appear this side, maybe. Somewhere here. Then the point is like this. So it's basically a reflection. Okay, that's all. So this will be the g inverse. Here will be the g function. This will be the g function. This will be the g inverse. Okay, so that's how you do it. Alright, next. Find f2, f3, f4 and f75. Okay, wait, let me just write down the fx again. So fx just now up there was x minus 2. Yeah. Okay, so we are looking for the first one, f2. Okay, question C. Looking for f2. f2 does not mean f square. Some people go and do, what they do is x minus 2 square. This is wrong. f2 means ff. That means like this, ff, which means you're substituting the fx here into the f itself again, which is fx is x minus 2, you substitute into x minus 2 again, so x minus 2 minus 2, so you get x minus 4. Okay, so this is f2. Okay, now f3 is what? f3 is you substituting f into f square. Okay, you're substituting the fx into the f2, which is what you got here. So what you will have is x minus 2 minus 4. So you get x minus 6. What else? f4. So f4 is what? f4 is f substitute into f3. Okay, f substitute into f3, so you get f4. Okay, so f3 is x minus 6, so you get x minus 2 minus 6, so you get x minus 8. So usually this question, they want you to see a pattern. So do you see any pattern? So the pattern is what? When the power here is 2, right? It becomes double it. You double the 2, you get 4. Okay, so you see here, this original one, the original one here, f, this one is power 1. So this times 2, you get 2 lah. Here 1 times 2 is 2. And then 2 times 2 is 4. And then 3 times 2 is 6. And so you get 6 here, 3 and 6. And when it's 4 times 2 is 8. Okay, so you have to be able to see the relationship. Because otherwise, how are you going to solve this? f75, are you going to do 75 times? No, right? You're not going to do 75 times. So you must be able to see the pattern. So the pattern here we can say is when the power is, let's say, n, okay, fn, then the answer, the function you will get is x minus 2 times of the n. So x minus 2n. So now since we are looking for f to the power of 75, that means x minus 2 times 75. Okay, so in other words, x equals to 75 times 2 is 150. So x minus 150. That is your f75x. Okay, so that's how you do it. You try to find the pattern first. Try to find the pattern, then you can find the answer.